Here is how we're going to start to solve quadratics. Okay, I want you to take your calculators. Here's what I want to know. When you graph this one, where does it cross the x-axis? You can look at my graph and see. Where does it cross the x-axis? No, the x-axis, not the y-axis. The x-axis.
3.
Oh, dearest children. The x-axis, where is it crossing? -2, -3. Do y'all see that now?
Is that not 3?
-2, -3.
Oh,
okay. All right. Can you see that on the graph? I know not on your graph because your calculator's messed up. But can you see it on my graph?
Yeah.
How it crosses at -2 and -3 on the x-axis. That means the zeros of this function are at -2 and -3. Zeros is another word for solutions. Okay? So if I was to factor this, I could use the shortcut. What multiplies to 6 and adds to 5? 2 and 3. So how are my x-intercepts, or my zeros, how are they related to my factors?
By moving left if it's a plus, or no, left if it's,
Okay, so we're going to do the zeros of these. What makes these zeros? The opposites, basically, in this case. We have a property called the zero product property that says if two things multiply to give you 0, then one of them has to be 0. There's no other way to get 0 as a product when you multiply unless one of the factors is 0. So we're going to use that information to solve by factoring. So let's do an example. We'll do a couple of examples and then we'll be done. Solve by factoring. X squared plus 3x equals 18. We're going to solve this one by factoring. What do you think the first step is going to be?
spread all like
Okay, so we need to factor it. But before we can factor it, this 18 needs to come over here. So the first step is to set the problem equal to 0. What happens to the 18 when I bring it over? Becomes -18. So I'm looking at this one, and I'm seeing that it's 3 terms. There's not a GCF, and there's an understood 1 in front. So in order to factor it, I'm going to use the shortcut, where I put the 2 x's. What number do I want my factors to multiply to? -18 and add to 3. 1 and 18, 2 and 9, 3 and 6, 6 and -3. Do I need to go back and divide by anything like I do on slip and slide? No. So step 1 was set it equal to 0. Step 2, factor. Step 3 is going to be to find the zeros of each factor. You can do that by setting each factor equal to 0 and then solve for x. You're going to set each factor equal to 0 and then solve for x. That means you're going to set x minus 3 equal to 0 and x plus 6 equal to 0. You do. You get x equals 3 and x equals -6. Now, if you want to go and check your work, you can take the 3 and plug it in here. That would be 3 squared, which is 9, plus 3 times 3, which is 9. 9 plus 9 is 18. You could also do the same thing with -6. -6 squared is 36. plus 3 times negative 6, that's negative 18. 36 minus 18 is 18. So both of these work. These are your solutions. If we were to graph this quadratic, we know that it would cross the x-axis at negative 6 and at positive 3. And thinking about what we know about quadratics, would that open up or down? Would open up, and what would be the y-intercept?
18.
Negative 18. Once you set it equal to 0 is when you see it. So our y-intercept would be way down here somewhere, and then it would cross at these two places. So it would look something like this. Any questions? It's just one extra step. After you factor it, set each factor equal to 0 and solve. So let's look at this problem. 2x squared minus 20x plus 42 equals 0. All right, so looking at this problem, it's already set equal to 0. So step 1 is done. Step 2. What is step 2? Factor. What's going to be my first step in factoring? GCF. A lot of you were thinking first times last. But you have to look. Does it have a GCF? Yes, it does. So factor that out. I factored out the GCF of 2. So I put the 2 on the outside, and I multiplied everything on the inside by 2. So that leaves me, divided everything by 2. Yeah, multiply wouldn't have made sense there, sorry. Now, in the previous lesson, we factored this trinomial right here. It has 3 terms. We can use the shortcut because it starts with x and x. So what multiplies to 21 and adds to negative 10? We said that was negative 7, negative 3. And then you got to put the 2 there. So that's step 2. It was already set equal to 0. So we factored. Now we're going to set each factor equal to 0. I put 2 equal to 0, but is 2 ever equal to 0? No. X minus 7 equals 0 gives us 7, and x minus 3 equals 0 gives us 3. So our answers are 7 and 3.
So just take the opposite way.
All right, here's our last example. Step 1. Set it equal to 0. So I need to bring that 9 over and make it negative.
You always have to bring it over?
Everything needs to be on the same side. The problem needs to be set equal to 0. All right, next step. After you set it equal to 0, what do you do? We're going to factor by doing what, Shani? First times last. There is no GCF, so we're going to do first times last, and that gives me negative 18. I'm doing slip and slide. Some of you do grouping. You can do it whichever way you want. I'm not going to put the equal 0 here while I factor. All right, so what multiplies to negative 18 and adds to 7? 2 and 9. But one of them needs to be negative because it's a negative 18. The 7 is positive. If the 7 is positive, that means our big number is positive. So negative 2, positive 9. But we're not done.
Is that 78 or negative 18?
Okay. What do we do now? We do what? We don't set them equal to 0 yet because we're not done factoring.
You bring your 2 down.
No, you gotta do it again for 9.
Okay, look. You see how we multiplied by 2? We got to go back and divide by 2. So that's going to be x minus 1 because 2 divided by 2 is 1. But 9 divided by 2 doesn't reduce.
But that means you have to bring it over to the front.
So what do I do?
Divide it.
Bring the 2 to the front. All right, now I have it factored. Now it's factored. After I factor it, how do I finish the problem? Set them equal to 0 and solve for x. So you get 1. This one takes a little bit longer because you have to subtract the 9 and divide by 2.